Happy Tuesday, everyone. I'm Lori DeToro, Communications Manager for Turntide Technologies. Thank you so much for joining us today to learn more about battery benefits and regulations and safety. We are thrilled to have George Patterson, VP of Product for Turntide, presenting with us this morning. Thank you so much, George, for joining us today.
Oh, you're welcome. It's a pleasure.
Awesome. So before we get started with the main presentation, I'm going to go through a few housekeeping notes just to help you know how to use the system, and then we'll let George present. Before we get started, I want to let you know that the presentation is being recorded and will be available on demand on the Current and Wave website. We will have time after the formal presentation to answer any questions you have. Please use the Q&A section, not the chat section, the Q&A section for your questions at any time during the webinar, and we will answer as many of those as we can before time is up. We also have a link for next month's webinar in the chat for you. So please feel free to register for that before you log out of this session. And also remember that we are doing this presentation live. So when something goes wrong or we mess up, and we probably will, laugh along with us. I think that's it for our housekeeping, and we are ready to get started. George, please take it away.
Okay, thanks very much, Laurie. Yeah, we went right to the wire. We were 2 minutes to go, and we were still working out the kind of presentation. So thanks for the introduction, Laurie, and welcome to all our attendees today. This, as Laurie said, is a part of our presentation series that we're doing at Turntide during 2025. So watch this space. We're going to have more future auditions. We also have a few in the past as well that are available. So today we're going to have a very high level look at EU battery regulations and really regulations that probably will apply globally at some point. We're going to look at some of the key points that you really need to know if you are designing batteries or actually procuring battery systems as well. So hopefully it's going to be useful. As I said, it's pretty high level. Okay, right. So who am I? So my name is George Patterson. As Laurie said, I'm VP of Product here at Turntide. I've been in the game quite a long time. So I've 40 years plus in manufacturing businesses. Started life, first half of life in the entertainment lighting industry, and then the last 26 years have been spent in the battery sector. I've held various roles over that time in engineering, commercial roles, and latterly in product roles. So I'm currently working with a small but dedicated team of product heads across Turntide's product range. We're defining product strategy, we're looking at product roadmaps and requirements, as well as a lot of other things that are required in product management. It used to be the case that we would manage products from cradle to grave. Nobody likes graves now. Everybody talks about cradle to cradle. We won't have second life use for a lot of the kind of products that we're developing. So that's a little bit about me. Before I really start, I'd really just like to thank Seth Yates, who is our product head for battery systems, and also Adrian Dockey, who is our director of energy storage, for actually mostly they put these slides together. They did a lot of the heavy lifting. They just left me to do the hard work of doing the presenting. So I really want to kind of thank those guys today. Okay, agenda-wise, I won't really be sharing any real proprietary or confidential information through this presentation. I think you'd all appreciate why that would be the case. It's just an open forum here. I think if there's more detail that you need, then happy to take things offline, happy to discuss things one-on-one at a later date, so you could get in touch with us at any time in the future. So as I said, it's going to be very high level. It's to really give awareness that could be helpful in choosing the right battery supplier, or actually if you're designing batteries or systems or integrating batteries into your specific systems or applications. And as Laurie said, the recordings will be available after the event. So today we're going to have, an overview about Turntide, just really who we are, what we do. We're going to introduce, because we're speaking about battery systems, I'm just going to very quickly show you some of the battery systems that we do. Battery requirements as well, we will discuss that very briefly. We'll then have a little bit of a deeper dive into battery regulations and really, trying to pick out the main points that's important to understand. We'll look at that. We'll do a case study. So I'll show you an example of what we've really had to deal with here at Turntide during our battery development over the last few months, actually, and it's actually still live. So I will discuss how live that is in a few minutes' time. And then we'll just cover a summary, a very, very short summary, and then we'll get on to Q&A. Okay, so hopefully that meets your expectations. So a little bit of a Turntide overview. A lot going on this slide, but really just, Turntide electrification was really brought together by 3 businesses which were based in northeast of England. That happened in 2021. And actually, my first time at Turntide, I've been in Turntide twice. My first time at Turntide was I joined in 2021, just when Turntide had acquired these 3 businesses. So the 3 businesses were BorgWarner Gateshead, which previously was called Sevcon. So Sevcon are a business that has 60 years experience, over 60 years experience in electrification, starting with fairly simple things like milk floats and forklift trucks, and then moving on to, I guess, more high performance applications like supercars, construction equipment, commercial vehicles, etc. So in that company, they were mainly specialising in power electronics, so inverters and DC-DCs. The other company that came together was Avid Technologies, and Avid Technologies, again from about 2008, were working on axial flux electric motors, cooling pumps and fans. Again, that was a small kind of privately owned business. And again, they grew over those first few years, a lot with government research programs, government funding, but then managed to work themselves into working on supercars and also military projects. Then the part of the business that I originally joined, which was Hyperdrive, and they were a battery business, again started in 2008. And they started working on utilizing battery cells and cell modules from the Nissan Leaf electric vehicle. The factory that makes those cell modules was actually just about 1 mile away from the battery factory that Hyperdrive had in Sunderland in the UK. That then gave Hyperdrive access to battery systems that were suitable for mini excavators, for autonomous guided vehicles, a lot of different applications, including marine, and also Hitachi train battery as well. And I'll go on to explore that a little bit later. Really, to summarise the company, we have over 60 years experience in electrification. We've estimated we have over 300,000 vehicles of all descriptions out in the marketplace using our products, whether that's cooling fans, pumps, power electronics, motors, and battery systems. Okay. So as I mentioned, some of our product range there. So we have 6 main product lines. We have axial flux motors, which are high torque and a compact design. We have motors that range from 100 to over 1,000 Newton meters, and also 60 to 376 kilowatts. Low voltage inverters again range from 20 volts up to about 106, and 190 to 230 amps. High voltage inverters a little bit higher, so 350, 700 volts. These tend to be lower power, so we call them HVLPs, high voltage low power, and they rate up to about 200 amps. Our modular battery systems, which I'll go into more detail, they start at 44 volts, can be used up to 400 volts, and we also have our large battery for a train as well, which we'll discuss. Just to wrap up, we also have cooling pumps, which run at 24 volts and 48 volts, and we have a range of 48 volt fans, which start at 10 inch, then 11 inch, going up to 15 inch. We have a range of verticals as well, so not all of the little pictures are included there, but our market verticals that we supply these products into include commercial vehicles, railroad, construction and mining, premium automotive, industrial, agricultural, defence, recreational, marine, and light commercial vehicles. So quite a large product range with lots of different variants working across the different vertical markets as well. So you can appreciate we have quite a lot going on in our business at Turntide at the moment. Our global footprint is growing. So we are now, all of the three business units are all really merged now in Gateshead. So that is our kind of headquarters really. That is our center of excellence. We have the design, we have simulation, we have test, validation, all there. We manufacture the motors, pumps and fans and battery systems also in Gateshead. And we have shared services, so customer support, applications engineering, supply chain, logistics center, and product management. Our company is headquartered in the US, in Atlanta. We also have an engineering group out in Waterloo, in Canada. So they do simulation, they also do test, design, and validation of power electronics and motors. And most recently in Pune in India, we have an Indian HQ where we have sales and application engineering. That's really a rapid growing market. So we're supporting rapid expansion in Pune. Just some of the customers that we have. So we are a trusted partner for a lot of these household names that you'll see here. We work again across lots of different verticals in this set here. So, and that is an ever-growing list as we expand across North America and India as well. So that will become a very busy slide in the near future. Okay, so that was an introduction just to let you know the products that we manufacture and the markets that we serve. A little bit of history there. Let's take a look. So we're talking specifically about battery regulations today. So I think it's only fair that I really give you a little bit of a heads up of the battery systems that we have here at Turntide. So this is a brand new product. This is our Gen 5 modular battery pack. It isn't really launched yet. It will be launched in the coming months. So some of the information I'm going to give you here is really live and it's up to date. So just some of the features on this pack. It's a modular pack. It's 44 volts and we have a couple of versions, a 4.5 and a 6.8 kilowatt hour. Again, what's prevalent to safety and what I'm going to talk about later is that we've actually got a safety vent built into this modular pack. That allows the controlled release of gases should there be a thermal runaway. That's going to be prevalent to what I'll show you shortly. These modular packs come with long cycle life, so we've done a lot of testing on the cells and the cell modules in the packs to make sure that the lifetime is very good, offers a good rate of return for the people who buy these packs, so the total cost of ownership is good. And we've made the modules flexible and scalable so we can series and parallel these up. And we also have a separate battery control unit called a BCU that goes along with these packs as well. Here's just a little bit of the data sheet. All our data sheets are available online, even for this new product. You could probably tell that the image on the right is a CAD image because actually the actual battery packs at the moment are actually still being built in the factory at the moment. So the best image that we have at the moment is actually a CAD image. That's really how new this product is. So here's just some of the data sheet information behind it. We then go from one extreme, which is 44-volt battery systems. We then have a larger battery system, which is 320 volts nominal. That's a 36.1 kilowatt hour capacity. And we use these in a combination of series and parallel to be run in a railroad application. So this through last year was being tested on the rail tracks in the UK. That project is now moving forward into the next phase of the project. So this was really kind of a demonstration prototype phase that we went through. This project was really 3-4 years in the making, as you could imagine, designing these battery systems, making sure that they're safe, reliable, durable. That's quite a task. So that really ran on the UK rail tracks for several months without any issue. So really happy about this project and the work that was carried out by the team. So as I say, we go low voltage systems and then we go crazily high on some of the higher voltage applications as well. Okay, so that lets you kind of understand the range of systems. Modular packs, very flexible. We've also got our larger systems are also flexible and can be seriesed and paralleled up. And then we have systems in between as well. So before we get on to talking about regulations, let's think about battery requirements. And you always like to think about, batteries are quite complex. I think when you've been doing batteries for as long as I have, 26 years, it's quite difficult. It's very difficult to have a battery that's going to be reliable, safe, serviceable, maintainable, and is going to really meet customers' requirements. And I think that really starts with understanding those customer requirements. So understanding what is the application. That's quite important. It could be flying in the sky, it could be subsea, it could be operating on the land, it could be working in cold conditions, warm conditions. So understanding the application, where it's going to be used is really, really important. Very important as well is understanding the drive and duty cycles. So is this product going to be repeatedly charged and discharged? Is it working in a hybrid mode? Is it a full EV mode? Is it going to be used every day? Is it going to be running in an environment where it's running 24/7? So we really need to understand that as well. Regulations, so that's what we're going to talk about very soon, is, regulations are always evolving. And what I've found in the early days of battery design, regulations were not that prevalent. There was not a lot of regulation in the early days of batteries. That meant it was a little bit of a free for all, if I'm being honest. But now I'm really happy to see that more and more regulations are coming in place. I think there's a benefit for all of us in this happening. And I think we need to think about regulations that are currently applicable and those that are also in the future as well. So, battery design can take a few years, so we have to be aware of when we're launched a product, are we going to meet the standards that are going to be required in the future? We also have to consider requirements from the customer, so they may have their own validation requirements as well that may be in addition to any kind of national or international standards that apply. In line with that as well, there's additional features. So maybe there's things like, onboard charging is required. Maybe there's remote monitoring. Maybe the battery has to operate in an explosive environment. So all these have to be considered. Then if we think about that, there's lots of design choices. So have a look on the right-hand side. We've got a lot of choices about, do we buy cell modules? Do we buy individual cells? Are they available? What format is the best format for the application? Is it a pouch cell? Is it cylindricals? Is it prismatics? Are we trying to design a battery that's power dense or energy dense or a really good mix of both? And really, what is the chemistry that we need to choose? So, there are many different base chemistries as well as different recipes within those chemistries. So it's quite complex. understanding all of the requirements, make sure we capture all of that. Then the actual design choices and making sure that you really meet the customer's expectations and also meet the regulations and standards that apply. I don't expect you to really kind of read this, so hey, what's the point in putting up something that's maybe not so easy to read? But this is just an example of requirements that we may receive from a customer. So that this customer in particular had a whole list of requirements they want our battery system to comply with. What we have to consider here is that there could be some overlap. So again, a lot of customers maybe just list a lot of standards that they need. It's really up to companies like Turnside and other good battery suppliers to really look through these, understand these requirements, understanding the regulations and standards that apply for certain applications. Some of these standards may be superseded by others. Maybe there's a hierarchy of standards as well that kind of come into play. Really, my takeaway here is that you need the experience to navigate around these. There's a lot of information, there's a lot of standards being requested. We just need to make sure that we're applying the correct ones. We need to give value for money to the customer. So, we don't want to be spending literally tens of millions of pounds in testing and very long periods of time. We need to rationalize that. We need to really come up with a sensible list of standards and regulations that apply. Okay, right. Really now getting into the battery regulations and having a little bit of a look at what's kind of going on here. So if we think about that, in December 2020, the European Commission proposed new battery regulations that, when adopted, would replace the current battery directive that has been going around for a number of years. These regulations are aimed to ensure that batteries that are placed on the market, specifically within Europe, but actually can be applied across different markets, are sustainable and safe throughout their life. The regulation started to apply on the 18th of February 2024, which was over a year ago. Actually, it's exactly a year ago. How coincidental is that? In contrast to the European directive, the European regulation is a legal act. So, that's now entered force, so it's now legal. It's not just really directives. And it applies automatically and uniformly in all European countries without the need to transpose these into national laws. Until the 18th of August 2025, the regulations will coexist with the Battery Directive, but from then on, the regulations will be the main EU legislation for batteries, since the Battery Directive will be repealed. During the transition period, the Battery Directive and the Battery Regulations are still valid. Okay, so what does this mean? What are the kind of key implications? So that was pretty high level stuff, right? So really from the implications here are really on sustainability and circular economy. So the regulations emphasizes sustainability, requires the manufacturers to ensure that batteries are designed with sustainability, maintainability and recyclability in mind. So this includes mandatory carbon footprint declarations, the use of recycled materials in battery production. The goal is to really promote that circular economy where batteries are reused, remanufactured, and recycled, and we take those, we look at the environmental responsibilities. Again, recently, if you look in press coverage, media coverage, there tends to be a lot of negativity around recyclability and sustainability of batteries. And I think these regulations are really just trying to address that. We're also looking at the key implications on this are also performance and durability. So, for battery manufacturers, that must mean that we meet stringent performance and durability standards. These include ensuring that the battery has a long life, can be easily removed and replaced. It's pretty important. There tends to be a culture of designing things that can't be fixed, that can't be repaired, and are just thrown away. We're really trying to look at that in the regulations now to make sure that's not the case. These requirements aim to enhance overall efficiency and reliability of electric vehicles, which I think it's critical for consumer acceptance and market growth. There's been a boom in EVs in the last few years. I think, again, as I mentioned, the last year there's been quite a lot of negative press about electric vehicles and about performance. How long will batteries last? I think these regulations are trying to gear this up, so we have a standard set of regulations that kind of prove how reliable and durable battery performance is, making it a little bit easier for those who procure batteries, and also then going to help the end customer who buy the electric vehicles. Maybe it's not just a car, maybe it's a thing like a mini excavator, maybe it's a dump truck, maybe it's an electric tractor. Some of the other key implications are traceability and transparency. So regulations introduce the concept of a battery passport. So that will be a digital record that will keep information about the battery's composition. As I said, there's a lot of different chemistries, there are a lot of different recipes even within those chemistries. So further down the line, 4, 5, 6 years down the line, we need to have access to that. We need to know how the battery can be best recycled, and we need to know what really went into the battery in the first place. We need to get the, a history, if there's, for helping with recycling. We also want to keep data about its performance, so that this is all of this information is transparent. It's readily available to customers, end users, etc. So that there is confidence in batteries. I think as well, a lot of the things that maybe hold electric vehicles a little bit back is value for second life use. Is my, how can I track the history? How do I know how it's going to perform? So by trying to get this digital passport that monitors this and is available, that could only be a really good thing, right, for consumers. And then, at the end of it, we're looking at recycling and waste management. So, hopefully before we send batteries for recycling, maybe there's opportunities for second life use. Maybe things that are working in a vehicle application can then maybe go into grid or stationary energy storage, which again just prolongs the life of the battery, prolongs the life of the materials. Eventually, the battery will have to be recycled. So it's really just making sure that the recycling processes are in place and that the manufacturers really take responsibility for the materials and the recycling of the batteries. Ethical sourcing, again, tends to get a little bit of bad press on batteries, especially looking at lithium and cobalt production. I guess everybody's seen pictures of child labour working in some mines. So I think this is really an important step forward to make sure that there is traceability and ethical sourcing of materials, that they're coming from the right place, that the environment is protected, and that no one is being exploited. And then really all of this should really mean that within the EU certainly there should be market competitiveness, right? So this is all about ensuring that batteries are designed properly, that the whole cradle to cradle has been really thought about. And I think this really, by trying to harmonize the standards, should make it easier for battery design companies, battery manufacturers to understand these regulations, make sure we're on a level playing field, and make sure that we're competitive in a global marketplace as well. Thinking about some of the other regulations that kind of come in as well. So we've CE marking. So this is CE marking applies to many products, whether It's a little plastic kid's toy, right up to battery systems, right up to electrical equipment. So CE marking is required for many products because it shows that the manufacturer has checked that these products meet safety regulations, health and environmental requirements for Europe. It's an indication of the product's compliance with legislation. It also allows free movement of product within Europe. And really, by placing a CE mark on a product, the manufacturer is declaring on their sole responsibility conformity with all the legal requirements that are achieved to do the CE marking. So the manufacturer is therefore ensuring validity of that product to be sold in the EU. This also applies to products made in third-party countries as well that are going to be sold in Europe. So anybody who wishes to sell their products in the European Union need to comply with the CE marking. So thinking a little bit about the detail, what does CE marking entail? So it means, drawn up technical documentation, risk assessments, carrying out the relative assessment procedure. It accompanies the battery with a user manual, including safety information and documents. Draws up a declaration of conformity, and that this would allow the CE mark to be added to the product. You need to keep that technical file, technical documentation for 10 years. And that would be open for the authorities to come and check in the future. It ensures continuous conformity as well. So again, if there's changes made to the product, some of the testing and validation may have to be carried out again. It means that the product should have a batch number, serial number, a product number, certainly for traceability. And who made the product, where it was made, information about how you could find the supplier should also be added either to the product or within the documentation that's supplied with the product. Technical documentation, so we're thinking about the design, the intended use of the battery, the application requirements and how the battery's conformity with the relevant requirements is reached. So we need to think about the test and verification programs. Any analysis and assessment of risks. A study to support the carbon footprint values in the carbon footprint class. Now, that I guess is a fair amount of work. The study also must support recycling content that's shared as well. So how does this apply to manufacturers? So manufacturers need to ensure these measures and monitors that the battery complies with the technical documentation and the applicable requirements. Again, still keeping on CE marking. There are notifiable bodies that can verify a lot of this, so TÜV, Intertek, etc. They can carry out examinations, calculations and measurements and check the battery's conformity with the applicable requirements. Issue a certificate of conformity. So really a lot of this is self-declarations, but if you feel more comfortable that you have a third party to do this, maybe looking at your calculations and measurements, etc., then that's absolutely fine. Identification number to the approved battery. So again, CE marks will apply to certain part numbers, so it doesn't necessarily just apply across a range. You would have to apply that to the particular battery. The manufacturer has to affix a CE mark to each battery that meets the applicable requirements. If it's not possible, if the objects or the batteries are too small, then you could actually add that to the documentation or packaging. And as I said, the manufacturer's got to kind of keep these for 10 years. So the EU declaration, the technical file, and also the certifications. I'm going to move away from CE marking now and just have a little bit think about battery passport. So the scope of the battery passport applies to industrial batteries that have capacities greater than 2 kilowatt hours. They apply to electric vehicles and LMTs, which are light means of transport batteries, so i.e. kind of e-bikes, e-scooters, that type of product. They must contain general information, the manufacturer's information, manufacturing location, batteries, data sheet. The real purpose of this is enhancing the transparency and the information exchange along the supply and value chains. So if we think about it, batteries may be sold to the first user, they may go into a second life use. In an electric vehicle, the battery or the vehicle may move between many owners. So this is the fact that this will keep a record that will be applicable. That electronic passport needs to be accessible via a QR code on the battery, which will then link to a digital record. The implementation for this is February the 18th, 2027. So again, that's exactly 2 years. It's the responsibility of the manufacturer and importers that must arrange this battery passport. Now, a lot of this is going to have to be thought from the beginning because it affects the design of the battery management system. It affects the information that you store within the battery as well. So this is not really something that can be that retrospect. It really has to be kind of thought from the real beginning about how this will be implemented. Supply chain due diligence obligations. So the scope of this is it applies to companies placing batteries on the EU market and putting batteries into service, specifically for raw materials like cobalt, graphite, lithium and nickel. Exemptions are companies that have a net turnover of less than 50 million euros or are not part of a larger group. So again, thinking about the supply chain, many smaller producers maybe don't really have that much pulling power or weight with their supply chain. So this is actually given a way that you can actually get out of this. The requirements are adopting and communicating a policy for the batteries, management systems, so establishing systems to support the due diligence policy, risk assessment, identifying and assessing risks in your upstream supply chain as well, and then design and implementing a strategy to respond to identified risks. Verification is third-party verification by a notifiable body is required for due diligence policies and their implementation. And again, this is effective from August the 18th, 2025. So that's not that far away. Waste management aspects to the regulations. So this really extends the producer's responsibility. So companies that first make batteries available on the market in an EU member state are responsible for the end of life collection and treatment of those batteries. So sometimes the end user will, they will accept that they can dispose of it, but really, if they don't, it's really up to the company who first places the battery on the market that are going to be responsible for this. There will be new targets for collection rates and recycling efficiencies as well that will come out with the new regulation. Again, this is extended to producers to be responsible, and register requirements will apply from August this year. Material recovery targets, so specifically looking to recover cobalt, copper, lead, lithium and nickel in the recycling and treatment facilities. The implementation date for the recovery targets will apply from, there's a little bit of time on this, from the 31st of December 2027. One of the standards that I wanted to kind of look at as well, because there's been a change that will be relevant when I come on to the case study, is that regarding the Regulation 100. So this is for road-going vehicles, and specifically looking at the battery testing. So one of the things that we've been dealing with recently is the slight change here, where we're talking about thermal propagation in a battery, and really what that means for end users. So the standard now really says, so if you look at the highlighted specifically on thermal propagation in the battery. At pack level, no external fire or explosion occurs within 5 minutes after the warning of a thermal event is activated. So really what that means is that's really to give. So if this was in an electric vehicle, if the battery gave a warning that there was a thermal event or there was an issue, there should be 5 minutes from that point of warning to allow passengers to exit the vehicle without them really being engulfed in smoke or there actually being a fire or an explosion. Okay, so that's really quite important. I think a lot of us drive cars, whether it's petrol or diesel. Quite a lot of us, I guess, drive electric vehicles like I do. I, for one, would want to know that, if there was a problem with the battery, that I actually had time to pull over and exit the vehicle. Now, you don't just get fires in electric vehicles. Obviously, you get fires in petrol and diesel. And actually, you're more likely to have a fire in a petrol and diesel vehicle than you are electric vehicles, actually. But that's a topic for another day, I think. Okay. Challenges and opportunities. So I think whilst the regulations are really going to increase compliance costs, it will also advance some of the technologies. So I think to make some of these, to be able to pass these requirements, these regulations, these standards, technology will have to advance as well, which I think is a good thing. I think manufacturers who adopt these regulations and can get their head around it and can meet these regulations should have a competitive advantage. I think if all the companies, applied these regulations and standards, then again, it's making sure that we have a level kind of playing field. I think these regulations seem sensible. They're about, I think given end users, given consumers, purchasers of battery systems, some kind of hope that what they're buying is good quality, is going to be reliable, robust, and ultimately safe, which I think is a good thing. And additionally, looking at recycling and ethical sourcing, I think also is a good brand reputation side to it, and it allows consumers to trust a brand. So in summary, it represents quite a major shift. As I said, in the early days when I was in the battery business, these regulations were just in the beginning, and they were a little bit disjointed, didn't really kind of caught up with technology. I think we're actually starting to get there now. I think, promoting the circular economy, promoting good ethics, I think can only be a good thing. So, as I say, it's a bit arduous, it's a lot of work, it's going to cost some money, but I think out of the end of it, it should be a better environment, should be a safer environment, and a greener environment as well. So just with the few minutes that we've kind of got left and trying to give some time for kind of Q&A, I'd just like to touch on a little case study that we came across recently. So again, I'm going to pull up this compliance to Reg 100, which said that we have to give the end user 5 minutes to be able to exit a vehicle. So why is this relevant? Well, we had to do some Reg 100 testing on our modular battery pack. Our modular battery pack contains either 2 or 3 VDA 355 modules, and we have to procure these modules. So to be able to complete the test, we need to have these specially prepared so that we can instigate a thermal event. So we actually have to put in an electric heater between the cells so that we can overheat a cell, make it go into thermal runaway, and then see what the results of that is. So why that's kind of relevant is that we started life, we designed a pack, we had a concept for the pack, we would make it in a plastic material, which would be, kind of lightweight, durable. However, when we started doing some pre-compliance testing, we actually found there was an issue. So with that thermal event, we were starting to deform the plastic. The inevitable gases that are released from a cell event were actually venting out from various areas on the battery module, which then actually resulted in a little fire, and then we actually got more fire. So really, this was really not going to be the solution. We looked at other ways of maybe containing the fire by putting in blankets, changing the materials on the plastic. However, it was decided that was going to compromise other things in the design and the performance of the battery. So we fairly quickly pivoted over to a metal housing. So we now have metal housing. We then did the same testing on the metal housing as we did on the plastic housing. We have a vent on the metal housing. We had a vent on the plastic housing as well. You could see in this case that, yeah, we did generate some smoke, which you would expect you have to release. You don't want to have a bomb in effect. You want to be able to let these gases be released, but you want to release them in a controllable manner that is repeatable every time you do the test. So this is what we did during pre-compliance. When the test was finished, other than some marking around the vent, which we would expect, the rest of the box was pretty much intact. So all of the controlled gases, all of the controlled smoke was all coming out as predicted through the one aperture. So this is now going, this was pre-compliance testing. So we did this, we are very lucky. We have local test facilities that allow us to kind of test this locally. That the battery packs are now being built up as we speak to go and get their final validation at a third-party test house so that we can comply with this regulation. So I think for us, this has been a learning curve. We learned a lot from going through this process, looking at different materials, looking at different venting strategies, etc. So this has been a valuable lesson, really being driven by the rules, and the rules for this are completely sensible, right? So in summary, last slide, new battery regulations are coming into force. They have a direct and immediate implication on battery manufacturers like ourselves. It ensures that battery suppliers are abreast of these changes, and choosing a quality partner that can meet these standards and give compliant battery packs is very important. So hopefully this has been useful. If there's other battery pack manufacturers out there, I would expect that you're doing this already, and that you're aware of all this. If you're out there procuring batteries, hopefully this is giving you food for thought, that you could come, you could ask the correct questions of your supply chain, and you come away from this a little bit better informed. We've spent quite a lot of time kind of going through this. Hopefully it's been useful. I haven't touched on functional safety or cyber security. Now, these are also regulations that apply to battery packs, okay? If there was an appetite, then we could certainly do more sessions talking about functional safety, talking about cybersecurity. They are actually huge subjects in their own right. And I'm sure Laurie would be happy to kind of set up additional sessions to kind of do it. I think looking at the time, I think we've got maybe about 10 minutes left on the session for any Q&A. So as I said, thanks very much. As I said, it was quite a whistle-stop tour of kind of going through it. It was quite high level, but even that took about 50 minutes to kind of get through that. So yeah, so let's see, Laurie, if we have any kind of questions.
We absolutely do. First, I want to thank you for that wonderful presentation, George. Appreciate it. We've gotten a lot of questions in. As we begin answering questions, please continue to ask more if you have them. We'll get to as many as we can. If we don't get to all the questions, we will post a Q&A blog with the answers on the Current and Wave website. So the first question we have, and the person who sent this then later parenthetically said marine applications. So I'm assuming this is specific to marine applications. Is a propagation test for thermal runaway required by an EU regulation, or is it mainly a requirement for type approval?
Good question. I think we were doing that propagation test because we wanted to CE mark. And so it's become part of the CE mark and the Reg 100. So when I was talking about earlier, you need to look at the list of standards that kind of apply to your application and your sector. So in this case, we were designing our modular pack that could be used in road-going vehicles. So we wanted to apply Reg 100. Now, Reg 100 actually applies at vehicle level as well. So what we wanted to do was give our customers as far down the road as we could so that actually the modular pack complied. There's more that needs to be done. So, saying a battery is Reg 100 compliant only takes it so far. So we, to be able to apply the CE mark, we had to then do the propagation test because we were trying to meet Reg 100 for the market that we were trying to sell the battery packs in. So long story short, understand the application, understand the rules and regulations that apply to those. Now, it could be if you're not trying to get CE mark in, you might go and do something else. You might want to look at the regulations that apply. So I know in kind of marine, they have like specific requirements in marine applications, like say DNV testing, etc. So it goes to the slide that I showed is, understand the application, what the mandatory regulations are, what maybe your customers are asking for, and then applying the standards that apply to that. So that CE marking was a point in case we were trying to achieve the CE marking, we had to do the propagation. So look at your particular applications. So that was maybe a long-winded answer, but I think it's just going through those and getting your expertise running through the standards to kind of see what applies. And it can be a bit of a rabbit warren, right? It's not easy, and certainly I'll tell you, I'll be honest, right? We went backwards and forwards many times to regulatory bodies to kind of go, does this apply? Does it not? Do we have to comply? Do we not? And then eventually, we actually had different answers to start with. And then we had to keep asking the question, and then we got consensus. So some of these things, although the regulations and standards are there and you think it's clear, you still need to do a little bit digging when you're looking at particular applications.
Fantastic. And that was not long-winded. It was very good.
Well, it was a bit long-winded, I'll be honest. As I say, it
So,
was long-winded trying to find some of the answers to these, to be honest. So,
yes.
yeah.
So, this is regarding a battery passport for a lead battery in a forklift. What's happened if during the life of a battery cell, another producer is used to replace a broken cell original?
That is actually a very good question. Well, so this is lead acid, are we speaking? Yeah. Was that lead acid you said, Laurie, or
He
just
said for a
generally?
lead battery. It didn't say lead acid, just lead battery.
Right. Okay. Well, we'll just talk about kind of batteries in general. In theory, so I think at system level, if you're replacing modules, then in theory that record should be updated. Now, how practical that's going to be, I think is going to be kind of interesting because I think on the battery passport, although there's an implementation date, I think the exact implementation of how that's going to work, I don't think is really fully 100% understood yet. So I think, from our point of view, and again, this touches a little bit on cybersecurity. So if you are in theory going to update the record on, say, the master controller or on the BMS, the fact that you've now replaced a module within a battery and you want to update that electronic record, that means you need access to that area. Um, that may have cybersecurity implications because actually you're overwriting the history or you're changing the history. So who has access to that? So I think that's going to be quite interesting. Now, it could be that at a very simple level that an electronic record needs, so like a service record, an electronic service record is kept. So again, if that links back following a QR code to an electronic service record, like for an electric vehicle or a diesel vehicle, then you could actually keep that electronic record that's off the battery and that's stored at the manufacturers, that actually just updates the service record to say that module was replaced on such and such a date. So as long as those records were available off the battery, then that's probably going to be acceptable. But I think how this is going to be managed, and I think as much as the technical aspect, I think it's going to be the logistics side of this that's going to be interesting about how this gets implemented, really.
Fantastic. So the next question is, how is Turntide making its batteries more recyclable?
Yeah, so what we're trying to do is we're trying to make our batteries more recyclable by making sure that we can easily strip those down into the individual components. So one of the things I said when we were, let's take the example of when we had the plastic housing. Now, we could have went down the road of basically just trying to suppress the fire. We could have, filled it with different chemicals. We could have put different coatings on the plastic. We could have put on fire blankets. We could have put on, other things to kind of contain that and suppress the fire for a little bit longer. We then kind of came to the conclusion that not only would that have a knock-on effect on performance, it could also affect the recyclability and the teardown of the battery. So when we're designing our battery systems, we're making sure that we can easily strip those back down. We can extract the module. We can then, that module that I showed the picture of, that then can be stripped down and that the cells can be extracted so that all the different constituent components can be recycled independently or as efficiently. Now, some battery designs where everything is basically filled with either fire suppression gunk or thermal propagation gunk, for want of a better word, that doesn't make that particularly easy to recycle. So, at that highest level of design, we're thinking about how do you strip this down? How do you disassemble this? How do you get that back to the constituent components? And that's thinking about how do you repair it? How do you maintain it? How do you design for recycling? So I think it's designed for recycling is really the answer there. Having a thought about how we would do that.
Okay, we have about 2 minutes, so
Yeah.
maybe a quick answer for this one. I'm going to ask one more. Is there an industry standard method for detecting a thermal runaway event to start the 5-minute warning timer? Off gas detection, heat detection, smoke detection.
Oh, that is a fantastic question.
That's why I wanted to ask it.
That is a fantastic question. So probably all of the above. And yeah, I think that's a great point actually, and that leads me in. So I'll try and answer this as quick as I can. In our modular pack, we are doing that by temperature. So we have multiple temperature sensors that sense. So when we do the test, we start the stopwatch from when we detect that temperature. Now, depending on how many temperature sensors you have, a temperature sensor may take, I don't know, 30 seconds to react, maybe more, maybe less, depending on where the event starts. So to that point, certainly in our modular packs, the temperature sensor is good enough. I mentioned the high voltage battery for the rail application. Now, because that is actually a large system, we've got large cells, we've got a lot of cells in those larger batteries. We are going probably belt and braces, right? So we are going to have temperature sensors, we are going to have pressure sensors, we are going to have gas detection, so that we make sure, because in a train that's different, right? Train, you need not just 5 minutes to evacuate a train, you need longer, like I think it's maybe 30 minutes, right? That's quite a long time. We want to detect any issues as soon as they happen. So our new BMS design that we're designing at the moment is going to have all of these sensors with the best chance of capturing something happening in the very, very early stages. So if thermal doesn't catch it, the gas detection may catch it, the pressure detection may catch it first. That may be vital. That maybe gives people an extra 20, 30 seconds potentially to escape. So we are deploying all of the above when we're looking at these battery packs. Obviously, they're large. They're going into an application that carries literally hundreds of people. We need to make those packs really, really as safe as we possibly can. So that was a great question. Thanks for that.
Of course. So that is all the time we have for today. We actually went a little bit over. Thank you again, George, for the wonderful presentation. We really appreciate it.
No wonder that no worries. Appreciative. There's a lot of words in there, but people can digest it in their own time. And as I said, happy to do kind of follow-ups on any questions that weren't answered. I'll probably pass them on to Seth and Adrian, who who did most of the work, and get them involved in this as well. And again, cybersecurity, functional safety, happy to kind of look at those in the future because, as I say, you could easily spend a few hours discussing those as well. So thanks again, Laurie,
Absolutely.
for setting this up, and thanks for everybody who attended today.
Yes, attendees, thank you for joining us as well. The webinar will be available on demand in about 48 hours. We hope you'll join us for our March 4th webinar, Disruption is Coming. The mobility industry must be ready with technology. And we hope you have a great rest of your week. Thank you again.
Okay, bye.